Here I am looking at 55 million-year-old fossils, and sometimes I ask myself, why should anybody care? But these fossils show the effects of a climate change a long time ago that's very much like what's going to happen in our near future. We're adding CO2 to the atmosphere right now faster than it's ever been added since at least this time 55 million years ago. We're expecting to see changes in climate a lot like the ones that happened in this distant period of global warming. We have very powerful models that simulate the future in computers, but we don't really know what's going to happen. And having a few good examples would be a tremendous advantage in understanding how the Earth might change under the global warming that's being caused by our adding CO2 to it. So increasingly, climate scientists are interested in what's happened in the past in order to better understand what might happen in the future. These fossils come from Wyoming, from a place called the Bighorn Basin, where I've been collecting fossils most of my life. And the reason I'm interested in them and the reason I keep going back there is because I'm interested in how climate has changed over geological time. And these particular fossils are from a period called the Paleocene-Eocene thermal maximum, an event that happened about 55.8 million years ago, after the dinosaurs were extinct, while the mammals were really in their first evolutionary radiation. And the reason I'm interested in that particular time period, right at the beginning of the Eocene, is because it's a period of very rapid global warming. And that's what these plants show. I'm able to make collections there and infer from the shapes of the leaves and their sizes something about the climate of the time, how warm it was, how much rainfall there was. And I'm also able to study these fossils very carefully and try to identify what kinds of plants they represent. And that allows me to reconstruct really kind of a record, almost like a movie, of how the composition, how the species that were present in that area changed over time. So we can look at floras that are 55.9 million, floras that are 55.8 million, floras that are 55.7 million, and build up a picture of how the forests changed over time. And that's really the main point of the fieldwork I do there. And what we've found out by doing that work is that, first of all, on land, just as has been observed in the ocean, there was a major increase in temperature over a very short time at the beginning of the Eocene. In a period of about 10,000 years, temperature rose something like 5 to 6 degrees Celsius. And also that rainfall decreased rather dramatically at the same time. And all of that change in the climate had a really dramatic effect on the plants. So we went from forests that would have looked something like forests in coastal South Carolina today to forests that would look something like forests in dry tropical Mexico or Central America today. Almost all the species are different, and the shapes and sizes of the leaves are different as well. So what we learn from this is that there have been periods in the past when global climate has changed very suddenly, when the plants also changed in response to that climate change. And we also know something now about how long this all takes, and that it took something like 150,000 years for the changes associated with that warming event at the beginning of the Eocene to dissipate. So a very long-lasting effect on plants and also on the animals that lived in these forests.